I'm Dr. Anita Warrier from Department of Physics, Met University. I'm here to give a talk on acoustics. Acoustics is the major topic for Engineering Physics 2, which is done by all the engineering program students. So as we start, my primary question is, what is acoustics? Acoustics is the term derived from the word acoustica, which is a Greek word, which means it's for hearing or being ready to hear. So when we talk of acoustics, we mean the three major processes on generation, propagation and reception of sound. So generation of sound happens by the vibration of air molecules, and these vibrating air molecules are transmitted through the air as a change in the pressure with the change in the density of air. And this change in density of air is perceived by our ears, and we thus receive these vibrations through our ears. So the scientific study of generation, propagation and reception of sound is called as acoustics. So why do we need sound? Why do we use sound? If you look at everything around us, we use sound basically for communication. Sound is also used for entertainment purpose in the form of music. It's used for detection of oil, gases, for finding earthquake, etc. So as you see, sound is basically used for communication, for talking with others, either through phone or directly, in the form of music for entertainment. It is used in the medical industry for ultrasound scanning. It is used for finding the oil and gases. It is used for determining the earthquake. It is also used for finding underwater acoustics, that is underwater objects. Sound waves are used in the form of sonar. So based on this, acoustics is classified into many forms. One of it is called as the general acoustics, animal acoustics, bioacoustics, architectural acoustics, medical acoustics and so on. So general acoustics is a study of sound wave generation, propagation and reception. So how a sound is created, how the sound is propagating through the air or through different mediums, and how it is received by a receiver or by your ears forms the study of general acoustics. It's used both for medical purpose and for research purpose on how to improve the quality of sound, how we can have different applications for the sound. Next is animal acoustics. Animal acoustics forms the study of how animals use, how they hear the sound and how they are generating the sound waves. So the sound waves they are generating and how they are using it is also used for the design of several instruments. For example, sonar, the sound, navigation and ranging. It's an instrument which we use for detecting several objects which are not perceivable or visible in the normal conditions. The next one is architectural acoustics. So the designing any architecture, for let it be a classroom, let it be an auditorium, let it be a monument of historical value, sound quality plays a very significant factor. For example, in designing the auditorium or a concert hall, we need to look into how the sound is being reflected, how it is transmitted, how it is absorbed, so that the quality of the sound is enhanced and the singer or the performer's voice is heard throughout the auditorium with complete clarity. It's also has been modulated, designed so that several interesting architectural monuments have been designed. So sound plays a significant role in designing the architecture, and we have to design an architecture depending on the quality of the sound that you need. Musical acoustics. So this is a study where we use acoustics to design music instruments to give the various quality of the sound, the various musics you get, the various rhythms, the timbre of the sound, etc. have been manipulated and designed to suit the different kinds of music we require for entertainment. So what is basically sound? Sound is, for example, you are vibrating a tuning fork. In creating this mechanical vibration of the tuning fork, you are actually vibrating the air molecules around the tuning fork. So this leads to the transmission of sound in the form of compression and rarefaction of the air molecules. So at certain points the density of the air molecules are increased, you call it as compression, which is a high pressure region, and the air molecules after that it goes into a low dense state, which is called as rarefaction, and the pressure is low here. So a sound wave is transmitted in the form of high pressure and low pressure waves in the form of compressions and rarefactions. Sound acquires a waveform, and the wave patterns are of two types, either they are transverse or they are longitudinal, and sound waves are called as longitudinal waves because the displacement of the particles, or rather the air molecules, are parallel with their propagation, whereas in the case of transverse wave, the displacement of particles are perpendicular to the direction of propagation. So, here as you see, the air molecules with increased pressure and decreased pressure are propagating along with the direction of, in parallel to the direction of propagation of sound waves, and it is the motion of these air molecules through the vibration of the air molecules through the medium which gives rise to the sound. And as we see, the sound cannot transmit in vacuum, and it always requires a medium such as a water, solid material, or air at least for its transmission. And you cannot hear sound or you cannot speak when you are in a complete vacuum. So, this is the reason why in space we cannot communicate directly to another person. Sound is a wave. It has a increased amplitude or decreased amplitude which varies with respect to time. So, based on that, the sound is of different characteristics which we call as its wavelength, its amplitude, its frequency, the velocity, the power, the intensity of the sound. Also, with these fundamental characteristics, we also have to focus on three major properties of sound, such as its pitch, timbre, and loudness. So, first let us talk about one of the important characteristics of sound, that is the velocity or the speed of sound. So, the velocity of the speed of sound in vacuum is 300, in a normal atmosphere is 330 kilometers per second, and this does not depend on the wavelength or frequency or any of these characteristics of the sound, but it purely depends on what is the medium through which the sound is being propagated. So, that is the reason why we see the transmission of sound is faster in liquids and solids rather than in gases, because the density of the molecules is more in the cases of solid and liquid compared to gas. So, what you see here in the slide is the picture of a sonic boom. So, the molecules you see, the cloud that you see around the airplane is nothing but the high density of air molecules surrounding the airplane. So, we call this as a sonic boom because it is nothing but a loud noise or a blasting sound that is generated when the shock waves are produced by an airplane which is traveling at a speed greater than that of the sound. So, whenever a person is in the field of this sonic boom or this shock waves, we hear a loud blast, and once beyond that field we do not hear the sound. So, this process is called as sonic boom, which happens whenever a jet plane or airplane travels at the velocity which is much higher than the speed of sound. So, the other two important characteristic of sound wave is a wavelength and a frequency. So, wavelength is nothing but the distance between the two crests or two troughs, or a distance between a maximum and the minimum of a wave, and frequency is nothing but the number of waves that are travelling per second through any medium. So, greater the number of waves we call the wave to be of high frequency, and if it is of lower number of waves are travelling per second, you call it as a wave of low frequency. The wavelength and frequency are interdependent quantities. You can say that the wavelength of a sound wave is directly inversely proportional to its frequency, and the proportionality constant is the velocity of the sound. Sound is also classified into two types. You call it as either music, or you also mention it as noise. So, when the sound is in the form of a music, you can observe it is a ordered sound and the noise is a disordered sound. So, you can differentiate music and noise as such. Music is something which is pleasant to hear and sound is totally unpleasant to hear. Music follows a rhythmic pattern or an ordered way of propagation, whereas a noise is rather disordered and it does not follow any kind of rhythm. In music, you can have a sudden variation in its amplitude, whereas a noise there is no such the music has periodic changes in the amplitude, whereas in noise there is no such periodicity. In music, you do not observe any sudden or rapid changes in its amplitude, whereas in noise the amplitude changes rapidly, as you see in the two pictures where music follows a periodic change in the wave pattern, whereas a noise is rather disoriented and fluctuating. So, the next property of sound is called as the pitch and the tuning. The pitch is a property of the sound which basically deals with depends on the frequency of the sound. So, we basically identify pitch as the difference between a low pitch which is of normally lower frequency and a high pitch which has a higher frequency. So, pitch of which high frequency, you can also identify it as a shrill voice, or rather which penetrates deep into the ears. So, the next important property of sound is timbre, or it is also called as the quality of the sound. Timbre is completely dependent on the features such as the musical note, the spectrum and the envelope of the sound. Timbre is also dependent on two important parameters, that is the pitch of the sound and the loudness. So, it is actually a combination of all these characters which decides the final quality of the sound. So, the quality of the sound from person to person varies depending on how they are going to mix and match the loudness, their pitch, the frequency and their the envelope of the entire sound spectrum that we are going to deliver. So, loudness is one important parameter which decides the quality of the sound. So, what is loudness? Loudness is actually a perception which can change from person to person depending on their likeness towards that particular sound. It depends on the intensity of the sound level. It also depends upon the detection ability or the sensitivity of the ears or the receiver which receives the sound. So, this is the reason why certain music is pleasant to your ears and you put on a higher volume, whereas certain music which may sound louder to a person prefers a lower volume. So, the loudness is measured in the unit of decibels, and loudness is determined from a law called as Weber-Fechner law. So, Weber-Fechner actually did an experiment to identify how the variation in sound intensity affects the loudness. So, it was found they do not have a direct relation, but it is the sound, loudness of the sound varies proportional to the log of the sound intensity. So, as the log intensity increases, the loudness takes a logarithmic pattern with a proportionality constant k. So, one important property of sound is the sound reflection. So, just like any wave, for example, a light wave, the sound also undergoes reflection. So, whatever we speak or the vibration of the air molecules, whenever it comes into contact with the obstacle, that is reflected back. So, this is called as sound reflection, and the sound can be reflected by any obstacle. For example, the walls of a building, the ceiling, the wooden materials or any metal basically reflects the sound, and the sound reflection is of two types. You either call it as an echo or you also call it as a reverberation. So, the sound reflection is used by several animals for identifying the obstacles. For example, if you look at a bat has a very weak eyesight, but once you observe the bat, you will find that they escape hitting any object, though they travel with a greater speed, and they never even once strike even a small insect. So, how does it do it? How it does is, it sends very high frequency waves of sound waves, which you call as the ultrasonic waves, which has a frequency greater than 20 kilohertz, and when these sound waves hit any obstacle, say for example a butterfly or an insect, these sound waves are reflected back, and the reflected sound is again detected by the bat, and it helps it in identifying that there is an obstacle present and the bat has to escape without hitting the obstacle. The only condition for such a reflection is that the sound waves should have a dimension which is much less than the size of the obstacles. So, the sound emanated by a bat is of ultrasonic waves or ultrasound, which has a wavelength which is very small, which is of the order of the size of insects. So, this is how, using sound reflection, a bat is able to escape from the obstacles. One of the best examples for sound reflection is echo. Echo is something which you hear when you are at a place of many mountains and valleys. So, whatever you speak hits the mountain and it comes back to you. So, if the distance between you and the reflecting wall is considerably large, you are able to hear the sound or sound produced by you again reflected back with much clarity with a certain time interval of few seconds. The next one is reverberation. It is also a process of sound reflection, but here the reflection happens multiple times. So, reverberation happens everywhere. So, at every time you speak, the sound waves emanated from you is reflected from all the obstacles that are surrounding you, and it undergoes multiple such reflections, and this process is called as reverberation. So, reverberation is a very important parameter which decides the quality of sound in a room. For example, if you look at a concert hall, if the concert hall is not designed appropriately, you will find that the sound is reverberated by everywhere, like from the chair or the walls, the stairs, and even the things carried by the people, so much that the actual voice or the sound produced by the singer or the performer is completely reduced, and the quality of the auditorium goes far below. The same happens in a classroom, where if it is not designed properly, the lecture given by a lecturer is not audible to every student present in it. So, care has to be taken in designing a room so that we control the reverberation according to your need. So, how do we control this reverberation? So, reverberation is controlled by first calculating something called as reverberation time in a room. So, what is reverberation time? Reverberation time is nothing but the time taken by the sound in a room to fall to average intensity, which is far less than the audible levels, that is, it reaches the inaudible level. That time is called as the reverberation time, or in other words, it can also be put as that it is a time in which the sound intensity reduces to 10 to the power 6 minus 6 of the initial intensity once the source has been shut down. For example, you speak a word, and the time taken for that particular word to completely die out is called as the reverberation time. So, it is also given as the ratio between the initial sound, final sound intensity to the initial sound intensity has to be 10 to the power minus 6. So, reverberation time can also be calculated in terms of its loudness. You can also say reverberation time is the time taken by the sound for its sound energy to diminish by 60 decibels. So, that if after the source has stopped. So, in terms of loudness also we can calculate what is the reverberation time. So, why the calculation of reverberation time is important, and why to understand the sound is important for designing of a room is a very important factor to be studied. So, by designing the reverberation and the reverberation time in a room appropriately, we can actually enhance the quality of the sound in a room. Apart from this, there are several factors which decide how the quality of sound in a room can be changed. For example, we can control the reflection by arranging appropriate materials in the room. For example, the furnishing in the room, like the curtains, the cushions arranged in an auditorium has to be such that it absorbs the sound in the room. So, any sound made by the audience in terms of whispers or any tapping sound can be absorbed by the cushions and the curtains, and it will not affect the performer's quality of sound. The other thing which affects the quality of sound in a room is the walking down of people through the stairs in the room. This is called as Echelon effect. By the tapping of the heels or the shoes on through stairs, it creates a sound reflection effect which can travel through the auditorium and create a louder noise much greater than the voice of the concert player or the performer. So, in order to have a better architecture for the room, we need to take care of its furnishing, and this is the reason why the stairs in an auditorium are always carpeted in a thicker manner. Apart from this, the space near the performer has to be such that the right amount of sound is reflected from him, so that the entire room is covered and they do not miss the regions where miss certain regions where the sound does not reach the audience. One more important factor in designing the auditorium is the ceilings. The ceiling has to be such that the sound does not reflect from the ceiling and it does not end up being focused into certain regions. So, this kind of sound lensing effect also has to be avoided, and care has to be taken in designing the ceilings appropriately. So, what are the factors which affect the reverberation? So, as we see, for any auditorium there has to be an optimum reverberation time, so that the quality is much enhanced inside the room. Some of the factors are the reflection. We need to control the sound reflection inside the room, that is any kind of metal chairs or metal tables in the room has to be avoided to avoid unnecessary reflections, and which leads to increased reverberation time. Sound absorption has to be controlled. Suppose the presence of sound materials with high sound absorbing properties present around the speaker, it can lead to the dying of the sound very quickly, and thus the quality of the sound will not be enhanced, and it may not even reach the audience at the last end of the auditorium. The frequency of the sound also has to be controlled well enough, so that the voice of the speaker is pleasant enough for the audience to hear. The intensity of the sound has to be controlled, and the loudness of the sound has to be controlled. This can be done by arranging proper speakers in the room. The volume of the hall also has to be adjusted along with the loudness and the other architecture, so that the audience have a pleasant experience of being in the concert hall. So, that is the end of the part 1 of the chapter on acoustics, where we studied on the classification of sound acoustics. The acoustics is classified based on their purpose, such as general acoustics, bioacoustics, medical acoustics, animal acoustics, etc. Next is the characteristics of sound waves, where the sound is classified based on their various properties, such as wavelength, frequency, the type of sound, that is it music or is it a sound, the pitch, quality, etc. The other important property of sound is how it is propagated, how it is reflected, and the basic difference between an echo and a property called as reverberation. Next, we also discussed on what is reverberation time and how reverberation time affects the quality of sound in the room, and how to design an auditorium based on the reverberation time and how you can control it to enhance the quality of sound in a room. On the next part on acoustic, we will be doing a derivation to find out what is the reverberation time, that is using Sabine's formula. Thank you.